Hey guys, so I'm standing here in the mouth of a cave, which you can kind of see goes all the way down deep into the ground here. A lot of these caves are formed through a process called karst topography. Karst is basically when all the glacier ice starts to seep into the ground, and then it'll melt, and then it'll freeze, and then it'll crack. And as it cracks, it kind of breaks apart the rock, pushing it apart and making caves like the one you see here. That water that's melting is going to continue to erode into the ground and into the rock, and it'll keep breaking and freezing and cracking and making more and more deeper caves. And that whole process and that whole landscape is called karst.
The reason why we have karst landscapes basically comes down to chemistry. In all of the liquids that we have on our planet, we kind of can rank them on a 1 to 14 scale according to something we call pH. And pH is a measure of how acidic something is. The most acidic things have a pH of 1. And those are the kinds of things that can eat your skin away and eat through countertops. They're really, really powerful acids. On the opposite end of the spectrum are things that are the most basic or alkaline, which is the opposite of something that is acidic. And we rank that at a 14. Just as dangerous, just as harmful. Bleach is in this category, really, really basic and can kill bacteria and can also be toxic to us. In the very middle is water, which we consider a neutral, and that's at a pH of 7. Some common acids that we'll find are things like vinegar, which I actually have in this cup right here. Vinegar is clear, but it clearly has a smell and can clean some things. Common bases we have are things like baking soda, which I have here in this jar. When an acid, oh, this is fun, look at my head. When an acid and a base react, we can see a chemical reaction take place a lot of the time. So if I mix a little bit of this vinegar with a little bit of the baking soda, it starts to bubble up. Now, this bubbling can happen anywhere. It doesn't have to happen in just a separate liquid. Sometimes these things are solidified in rocks. One example is limestone, which has a lot of calcium. The calcium in limestone comes from all of the fossilized fish and shells and other things at the bottom of the ocean that settle down as things die over time. Well, those fish bones and shell casings, they have a lot of calcium, and that's really alkaline. And when acid gets into it, it can cause a reaction. It can create little holes, it can dissolve what's there. To show you what that looks like, I have 2 pieces of limestone here. Both of them have a lot of calcium in them. I've got a glass of water, I've got a glass of vinegar. Let's see what happens when I drop both of these in. Now, you can find limestone pretty easily. It's often in gravel that you find in gravel pavements. You could definitely try this at home as well. But let's take a look. What do you notice happening in this jar compared to this jar? You should see something rising up out of this jar, and that's a chemical reaction taking place. These little bubbles that you can see are coming directly out of the rock. The calcium that's in this rock from the limestone is getting dissolved by the acid that is this vinegar. Well, things like water in nature often have stuff in them that might make them more acidic. Pollution can actually make the rain more acidic too. Things like sulfur dioxide, which come out of our coal-fired power plants, have a lot of acid in them. And when acidic rain or just acidic water ends up in the rocks and the limestone areas, it can break down this rock over time. After a long period of time, the entire water can kind of get this cloudy look to it. This is a piece of limestone that's been in the acid for a long time, and a lot of it has already dissolved out. But if you imagine this as a giant piece of crust, it forms little holes inside, which on the scale of the earth become caves, become sinkholes, and all the other kinds of formations that we can see. Also, it's kind of slimy on the outside from everything that's come off of it.